Hello, so today I'm going over homework 8 for the class EEDG 6370 offered at UTD in the fall of 2024. So at this point, we have already downloaded the Linux distribution onto the microSD card and verified that it works, and I will now show a video of that. Okay, so here we have the FPGA. We have a microSD card with Linux flashed onto it. We have a USB connected to this keyboard right here, and then we have the VGA cable connected to the monitor right here. So now you can see that the Linux is booting, and now the Linux is booted, and let's type in root, and you can see now our location, so you can see we're in the home root. And then let's do ls. You can see that we have a few files here, and that's about it. And so now that you see the Linux is actually working on the board, so first off, I'm just going to take this very simple C program that just prints this message. It starts off with hello UTD student. Technically, what is asked for is for it to say hello UTD. So I'm going to slightly modify it to say that. And then what I'm going to do is now compile this. So over here, you can see I'm in a shell, and we get to that by using this embedded command shell.bat, and that's in the C folder under the Intel FPGA 20.1 embedded. So if we do a make clean, we are back at the original state. So we have a main.c and a make file. This main.c is this file right here. And what we can now do is just run make, and it'll produce the outputs, which are the main.o and the myfirstHPS file. So I actually just ran this ls-lh command, and right here we can see that the generated file, the myfirstHPS file, is actually 14 kilobytes. And so on the FPGA, I ran a few commands to get the IP, and let me just go back here. So this command will copy the myfirstHPS file to the 192.168.68.64, which is the IP address on the FPGA, and it will copy it to this location. And I'll just hit yes, and then type in the password that I made for the FPGA. And right there you can see that it copied over the file. And now what you can see on this webcam is I'm in the Linux environment on the FPGA. And so I'm going to just type in this ls-l command. And what you can see over here is the myfirstHPS file. And you can see its size, the 14,276 bytes. And so now what we're going to do is we are going to modify this so that it can run. We're going to modify it so it can run. We're going to use the chmod 777 and then the myfirstHPS. So now it should be able to be executed. And now we are going to run the ./myfirstHPS. And what you can see right here is that it says hello UTD. So now you can see the process for compiling a software only design and then copying that over to the FPGA and running it. Okay, so now we are going to show you the second part, and I will be going through the software first. So first we include the standard IO library, and then we include a Unix standard library, and then we can include the fcntl header, which is for controlling file descriptors, and then we include this sysmman.h header, and that's used for memory mapped files. And then we include this hardware lib header, which will allow us to communicate with the different FPGA hardware. through like the GPIOs and whatnot. And then we include the socal, socal.h, aps.h, and alt gpio.h files. I'm not exactly certain what these do. I mean, I can assume that this has to do with the some of the definitions for the hardware processor, and this has to do with some of the GPIO definitions. But other than that, I am not entirely certain. And so then we go into defining some of the hardware memory locations. So we define a base address for the registers. We define the span of the registers, and then we define a mask for the registers. And then right here, we define the direction of the I/O, and then we define the bit that is used for the LED, which has been designated as an output, and we define the bit for the button. And then we get into the overall code. And here you can see we create a void pointer named virtual base. We create an integer called fd. We create an unsigned 32-bit integer called scan input. And then we create another input I. And then I believe right here what's going on is we're accessing the memory, and we are creating like a memory map for it and assigning it to the virtual base. And then right here, we just make sure that the mapping properly happened. If it didn't, it'll error out. It'll send a message and close the memory, and return a 1 to signify that the program has exited with a fault. And then down here, basically this will set the direction of the GPIO headers. So it'll set the LED and the button direction. And then right here, we say that the LED test is starting. And then we say that the LED test will flash the LED 2 times. And so then we go into a for loop. And then this line of code enables the LED. Then we sleep for 500 milliseconds. And then we clear the bit. So now the LED will be turned off. And then we sleep for another 500 milliseconds. And now we start the key test. So we print that to the user, and we tell the user to control the LED with the key. And this key is a little push button on the board. And then we enter this while loop. And right here, we take the input of the key, and we check that it has been pressed. And when it gets pressed, then we set the bit driving the LED. And if it is not pressed, then we clear the bit driving the LED. And then it tries to clear up the memory. So it'll basically try to unmap it. And if it fails, then it'll close the memory. It'll print a message saying that it failed, and they'll close it and return with an error. Otherwise, if the unmapping succeeds, then it'll close and it'll return a 0. Okay, so now that I have told you how the program works, we will make it. So we'll run make, and then we will copy it over to the board using this SCP HPS GPIO root at the IP address that I had previously told you about. And so let's get that copied over. We'll type yes, confirm it, and we'll type the password. And now that file has been copied over. It's a 14 kilobyte file. So just ls minus l. So it's 14.736. So 14,736 bytes. Okay, so now I just made the program and I've flashed it over to the FPGA board. And so what I'm going to do is I'm going to add permission to run the program, and I'm going to run the program. And what you can see is it says it'll flash 2 times, and then it'll press key to control LED, and I'll just show you the controlling the LED part right now. So over here, you see this LED right there? It's controlled when you press this key. And now I will go back and I will exit the program. And then I will run it again and I will show you the LEDs flashing. My bad. So that was the first LED test where they flashed the two LEDs. And you can see again that the program then goes to the other test. And that's it working. Thank you very much. Okay, so now I've shown the program working with all the peripherals. Thank you for watching.